Hello, and welcome to Sequential Logic Structures. Forgive me kind of how I'm doing this. I'm not going to put this in a PowerPoint presentation because I kind of want to write and make some notes as I'm going through this presentation. I'm probably going to do this from time to time. So, though it's not very pretty, I hope you still enjoy it, okay? Anyway, let's talk about sequential logic structures. That's our next topic here. As you know, there's three structures of programming: sequential, conditional, and iteration. The first one being sequential. For the most part, the simplest of all the logic structures. Things you need to know about it. It's a logic structure, a sequential logic or sequential is a task. It is one thing. It must be executed top down. Make sure you get that. That the order and actually you put the task in is the order it's going to be executed. I know that makes so much sense, but in some cases I've seen students just think because they have it in the algorithm, it's going to run when it needs to run. No, you need to tell it exactly when it needs to run. And you have to put it in the order from a top-down way of the task necessary, meaning you don't pour a can of Coke out until you open up the can. So if you had an algorithm that said, how to fill a glass of Coke, you wouldn't say pour until you actually said open. Does that make sense? So open would be first, then pour, and then put down, then drink, I guess you would say. It would be a nice way of doing three tasks to actually accomplish opening up a can of Coke and taking a drink. All right? Hope that makes sense a little bit. So must be executed top down, must complete before moving on to the next task. I guess what I'm saying here is that I must complete the opening of the can before I can actually start pouring the can. Everything that you do when it comes to programming and so on, the task has to complete. You can't be doing two things at one time. I know we as human beings try to do that, but we don't very well do that. Texting and driving, probably one that I think of right now. Don't do that. Anyway, I'm sitting on my little pulpit here telling people don't do that. Anyway, but you get the idea. You have to complete the task completely before you can move on to the next task. And that's how you do this in programming, okay? So make sure of that. We're not a multitasking scenario when it comes to programming. We can't execute two things at one time. Okay? Keep tasks as simple as possible. It's not necessary to impress me or the computer with trying to do too many things in one calculation. I actually saw the book trying to do that. I'd rather you break up calculations and make them a little bit easier for you to understand and so on. Now, the computer doesn't care if you try to stick it all on one line when we get to programming. As a matter of fact, the computer will break it down its own way and keep it simple. So for the sake of your readability and my understanding and the people who might follow you to actually try to understand your algorithm, it might be best to try to split it up and keep it as simple as possible. So hopefully you kind of get the idea there. And I'll show you an example here in a second. All right. Finally, though I like the IPO charts and how the book states to complete an algorithm, which I think it does a pretty good job with this, a flowchart is not necessary in your IPO. Okay, if you like flowcharting, use it. I like pseudocode, and that's all that's really required for my assignments. The flowchart is there to help you one more time, and maybe in another way, a more illustrative type of way to help you maybe understand things. So it's up to you if you want to use them. I find them after a while to be cumbersome, meaning you might run out of paper and go to the back page and so on and so on. But it's strictly up to you, okay? Also, what your book does, and I kind of mentioned this in some of my instructions, so I kind of want to get this out of the way now. I felt the last couple of chapters of your book kind of went ahead further than what really needs to be happening right now in your programming career, if you will. I don't really care at this point in time about modules. It's not necessary for us to be breaking things down into modules at this point in time. Later on, that makes a lot of sense, and we'll do that in .NET 1, which will probably make more sense to you. But right now, it's not necessary. So if you read about that, that's fine, but I'm not expecting anybody to be breaking anything down with modules. So thus, a structure chart is not required. So when I tell you not to read certain things like couplings and navigation and data dictionaries and modules and so on, please disregard that. And if I give you any problem that I want you to do in the book and it mentions doing something in a module, please disregard that. You can do the problem, but don't worry about doing anything in a module. I do not care about you understanding modules at this point in time at all. Make sense? Okay, good. One of the things you're going to be seeing now, we're getting away from our little daily life type stuff of brushing our teeth and starting the car, and even getting away from the mechanical man. Now we're actually starting to get into, and as we're going to start this week into multiple weeks, is getting into actually processing data. Once again, what we do as programmers is we take data in and we process it to create information. That's what we do. We do this in all different types of ways, and information comes in all different media. It comes in all different forms, shapes, and sizes. But as programmers, as software developers, that's what we do. So right now, we might as well start getting used to the idea that we're going to be taking data and processing it. So these problems you're going to be working on is going to be a lot of calculations in them and so on, especially this week and subsequent weeks, I should say. But just get used to it. No big deal. It's what we do. Okay. Though you may look at some of these calculations, you might say, I don't know how to figure out the math. Math is not really required here, but just try to keep it as simple as you possibly can. If you don't understand how to do the math, don't be embarrassed by that. Just ask me. Send me an email, sit back and say, I don't know how to calculate this. I'm not going to ridicule you. I'll just give you the answer on how to go about doing some of these things, okay? I would assume you know enough math to be able to do the calculations that most of these problems are requiring of you, okay? Anyway, that's sequential logic structure. As you can see, it didn't really require putting together a big PowerPoint presentation. Your book does a nice job of explaining it, pretty much exactly what I explained. What I want to do now is kind of walk through a couple of the examples of what, and see if it lets you kind of go off and do your own. As I said before in the instructions, this should be a relatively easy week. It should get you started as we kind of introduced everything a little bit. Now let's go back and take things one step at a time. This week will be sequential. The next 2 weeks will be conditional, which really gets us into really, logic, if you will. And the final week will be iteration. Does that make sense? So this week should be a pretty simple week, one that you should sit back, kind of enjoy a little bit, hopefully get caught up on everything else, and make sure you truly understand how to kind of practice a little bit with writing an IPO, or at least the way I want you to do it, I should say, kind of a modified IPO. Okay? Anyway, with that said, let's go down here and let's look at this particular algorithm that somebody wants me to write. Determine the price of concert tickets based on a price of $50 each and a discount of 20%. Okay? Writing a couple things in there. Once again, sort of like how your book explains it, the IPO, one of the things I want to understand is what is my inputs and what is my outputs. Then we're going to determine the process of actually getting there, right? Your book does a great job of splitting that up. That's why I kind of like the IPO chart. And once again, if you want to put a flow chart in there, by all means do so, but it's not necessary. So my modified version of this is figure out what the inputs are. This is sort of a vague question. Nobody says I'm giving you this. What would the inputs be? Determine the price of concert tickets based on a price of $50 each and a discount of 20%. You might assume there's only one ticket or two tickets or how many tickets. That might be a question you go back and ask your user. Am I supposed to do this for a certain number of tickets? The answer for this one could be yes. So one of my inputs, I would say, would be, number of tickets. So I'm going to say tickets sold, if you will. Is that all right? So tickets sold, how many tickets are we actually buying? So if I'm actually buying 1, 2, 3, 4, 5, this variable called tickets sold basically represents the number of tickets that are actually coming in that I'm being, sold to. Okay? That's all I really need to know. And my output is going to be my total price. Pretty simple, right? So with that said, I sit back and I always kind of tell people, where do you start with this? Well, you go get your input. You can sit back and very easily say, go get your input. I say get input when I'm writing my algorithm. In this case, I might say get tickets sold. Okay, so if tickets sold in this case, well, let's just finish this thing up. So tickets sold basically represents the actual number of tickets that we're buying. Okay? Okay? In this case here, what I want to know is how much is it going to cost? Well, maybe in this case, I'm going to break this thing up. Again, I can do this all in one calculation, but I like simplicity. Let's go for the simplistic way first, and then we can maybe look at how we can merge it all together like I think your book kind of does, and maybe some of you want to do it. So if we sit back and we look at this, if I do it this way, I can sit back and say, Total, how about subtotal? Subtotal equals tickets sold times $50. So basically what this is that I'm sitting back saying, if I have 5 tickets, I'm buying 5 tickets, they're $50 each, my subtotal is going to be $250. But my total price is going to equal subtotal, right, times, in this case, I have a discount here of 20%. I can write this a couple of different ways, but one of the quick ways I can write it is that my subtotal is going to be 80%, I'm sorry, my total price is going to be 80% of my subtotal, meaning I have a discount of 20%. Or I can write it like this, 1 minus 0.20, which is basically going to be 80%, right? So 1 as a whole in this, so I'm taking 1 minus 0.20, in this case, 80%, times subtotal. And that's going to be my total price. Your book always kind of has something like print total price in there. You can actually put that in there. What do you think? So let's test this, shall we? So if I have, in this case here, I'm going to try to keep this a little bit simple. My tickets sold, my input, if tickets sold, is equal to 4. What's my total price going to be? Well, let's kind of think about this in a head. What's our expected results? $200, 80% of that. So 80% of 200, help me. Yeah, $160 is what it actually should come out to be. So if I walk through my algorithm, which starts right here, I get my tickets sold. There it is right there, 4. 4 times 50 equals $200. 200 times 1 minus 0.20. Remember, everything in parentheses is done first. So 1 minus 2.8 is 80. So 0.80 times 200 is $160. So I'm going to be printing $160. And in this case, my algorithm works. One of the things we're going to talk about in a couple weeks in a little bit more detail is testing. But what you see here is that it worked. How much more testing do I need to do with this? Should I then test it to see if what will happen if I buy 1 ticket, okay, or 2 tickets or 5 tickets? In this case, if it works once, it will always work. But if I do have 1 ticket here, okay, because I have 1 path is what I'm saying. Let me go back on this, make sure this is clear. One of the things you're going to notice as a programmer when you get into these algorithms, you want to make sure you test the paths. What do I mean by paths? Well, you've already been introduced a little bit to some decision making, the if-else's and so on. If A equals B, then do this. That's a path. Else, do this. That's another path. In this case, since there is no fork in the road, if you will, it's 1 path. Think about a path from, your desk to the door. It's 1 path. There is no, alterations if I go this way or that way or whatever. It's 1 path. All you need to do is test this once, and it works. If it worked for 4, it'll work for 1. In this case, 1 times 50 equals 50. 80% of that, my total price is going to be $40. It works fine. You don't need to keep testing this. That's the beautiful piece about testing. If you learn how to test correctly, and we're going to work on that a little bit here in the next couple weeks, you don't have to spend hours doing so, but you can also guarantee that everything works. That's what we want to get to. That's the magic. Trust me, people don't do that. They test the same path over and over and over again and forget to test the other paths, and then all of a sudden a user will come in and do the other paths and it breaks. Does that make sense? Anyway, I'm digressing a little bit and I apologize. But in this case here, this is how we would write this thing right here. Yes, you could do something like this. Tickets sold times 50 times 0.80. And forget about the subtotal. Let's see, control. And put it all in 1 line. I'm fine with that. But I'm telling you, you already learned what a compiler is, right? That's when you take the source code, compile it down to the machine language. What's going to happen in that compiler is going to break this thing up. It's going to break it up and to put it into a couple different calculations. So when it does, it's going to do that automatically. So for you, if it's simpler to take one step at a time throughout your calculations, do so. I actually applaud it. Don't make these things so difficult. In this case, this is not very difficult, but you get the idea. Excuse me. Okay? So a couple different ways of solving this problem. All right, let's look at another one. This one came out of your book. I think this is a pretty good one. One of the jobs that Joe Roberts has been given at work is to order special paper for a report for a board meeting. The paper comes in reams of 500 sheets. He always makes five more copies than the number of people that will be there. He can order only whole, not partial reams. Joe wants to know how many reams of paper he will need for the board meeting. So once again, when we break down our problem, we got to understand what our inputs are and our outputs. In this case, he wants to know how many reams of paper. We can sit back and say that's our output. But what are our inputs? What is it that we need to know to be able to solve this problem? This problem is a little bit vague in a lot of ways, but what is it we need to know? Any ideas? Probably two things. Number one, let's see. The paper comes in reams of 500 sheets. He will always make 5 more copies than this. So I guess I need to know how many copies he wants and how many sheets of paper, sheets per copy. Do you agree with that? Once again, it's kind of vague, but I think when you kind of get into this and you read between the lines, that's what we're looking at. He needs to make copies. He has 500 sheets. We need to know how many sheets are in per copy, meaning how big is this report, then actually how many copies he needs. What do you think? And the output is going to be reams of paper. So you get that by kind of analyzing this up here a little bit more. Take your time, look at this a little bit, stop this video if you need to, and read that paragraph and make sure you agree with me in regards to what our inputs are. Okay? So let's solve this thing. So in this case, once again, I'm going to get my inputs. I like saying that. In this case, get copies, and that's basically saying how many copies, and sheets per copy. Okay, so in this case here, I need to figure out how many copies we need and how many sheets of paper we're going to need, and then kind of go from there. Well, my copies is going to actually be, if you remember what he said, copies is copies we actually need plus 5, because Joe always makes 5 more. So I'm sort of accumulating here, right? So whatever the copies were coming in, I'm going to add 5 to it, and that's going to be my new number here. Then my sheets of paper, sheets needed we're going to say, which is going to be a new variable, will be equal to sheets per copy. So if our report is 20, let's say it's 20 pages long, it's going to be 20 times my copies, is it not? What do you think? So I get my copies, I get my sheets per copy. This is a 20 copy report, 20 page report I should say. I know I need 20 copies. I'm going to make 25 copies, so I always make 5 more, correct? And so my sheets per copy, so 20 times 25 is actually how many sheets I actually need, correct? Then in this case here, I need to figure out how many reams I actually need. So reams is going to equal, in this case, how are we going to do it, people? How are we going to do it? Probably in this case here, we're going to sit back and we're going to say sheets needed divided by 500. So if I had 500 sheets needed divided by 500, I need 1 ream. I had 1,000 divided by 500, I need 2 reams. If I need 300 divided by 500, it would basically be this right here, point whatever, correct? And in this case, display reams. Now it's interesting this thing stated this, and I'm sure you probably read in the one chapter that what we need to do here is make sure this is basically a certain data type. I told you not to worry about it too much, but how we're going to make sure that we're actually getting at least 1 in there. It's going to round up. We're going to make sure it's an integer division. Integer division is basically a /. You see that right there? Meaning this will round up to a whole number. No matter what we do, this will round up to a whole number. That's what we actually want, okay? So in this case here, that's how we would actually write this. Once again, let's kind of test this thing out. Our copies, we'll say, are equal to 5. Our sheets per copy, I'm going to make this easy on us. Sheets per copy is equal to 10, okay? I'm going to come in here, get copies. I did 5. Sheets per copy, I did 10. Copies plus 5 equals 10. So now my copies are 10. Sheets per copy times copies, okay, is, okay, I'm sorry, I'm going to make this, change this around in a second here, but sheets per copy, which we said is 10, times copies, we need 100 sheets. So 100 divided by 500 is going to be, what, 0.5, right? Is that right? Well, basically 0.4, 0.5. I don't know. It's going to come up to something. You know, it's going to be a fraction in this case. And because this is integer division, this piece right here, reams will end up being 1, and that's what one we actually need. Let's make this a little bit more realistic and say our sheets per copy is 100. Copies is 5. Sheets per copy is now 100. Copies plus 5 makes I need 10 copies. 10 copies of sheets of 100. I need 1,000 sheets. 1,000 integer division by 500. I'm going to need 2 reams. And that's how we would write, and we just display the reams. That's how we would write this. Very simple, if you will. I don't know if it's overly simple, but basically this sequential type of algorithm. Probably a little bit more involved than you actually thought it would. But what do you think? Does that make sense? I hope it does. So we just did one thing at a time. We went and got our inputs. I added 5 copies because it told me to do so, because the paper comes in reams of 500 sheets. He always makes 5 more copies than the number of people that will be there. So if I know there's going to be 5 people there, I add 5 more. That's the copies I'm going to need. My sheets per copy times copies, that's how many sheets I need. I'm going to divide that by 500. This little integer division thing might be a little confusing, but it was actually talked about in the previous chapter. No big deal if you understand that or not. I'm not going to use it very often, but that's how we would go about doing this particular example of a sequential logic structure. I hope this is pretty easy to you. Once again, step by step, make sure you don't try to do too much on any particular line. And again, you see my little modified IPO, what my inputs, what my outputs are, and then I start writing the process, okay? If you want to use how the book does it, makes it a little bit more organized for you, by all means do so. The outcome is the same, okay? That's it on sequential input structure. Good luck on your assignments this week. There's a few more than a few out there I want you to practice on. Take your time and try to get through them. Hopefully, like I said, it's going to be a pretty easy week for you. Walk through it. Make sure you don't get too carried away, and test it. And I also recommend when you do test it, give your friends some of the data and have them test it to see if it comes out with your expected results. That's a great way of testing. If you try to test it, sometimes you get too, we want to say, intimate with it, and all those assumptions that if you have about your algorithm come true. Tell them to do exactly what you said you're going to, exactly what it says to do here, and let's see what the answers are. Great way of testing. Okay? Until next week.